Thank you very much for the wonderful introduction, and it's a big pleasure to have Vangelis Papadopoulos speak before me, who was actually also an MIT alumni. And we're in many respects quite complementary to Vangelis. So Vangelis provided you with a large coverage of the full spectrum, if you want, of robotics nowadays. I will concentrate more on things that have to do with human-robot interaction and artificial intelligence. Vangelis is coming much more from the mechanical engineering and the electrical engineering side. I'm coming much more from computer science and all that the Media Lab is representing, which has to do in the end with a more sort of psychological and holistic perception and a little more architectural and societal perception of things. So it's a great pleasure to be here in Athens at the Eugenides Foundation, participating in this event. And my pleasure is even greater given the fact that the event is organized by the MIT Enterprise Forum. Not only as an alumni of MIT myself, but even more so given the times that we are in and the recent situation that exists in the European Union and in Greece. This might be difficult times in many respects, but I think that there are also times of a big opportunity, and I hope that MIT-EF will help us be able to fulfill the promise of this opportunity and unleash all of the hidden and unutilized creative powers of the youth of Greece and Europe. My talk is entitled Opportunities at the Fertile Crossroads between 4 different things, and I will also provide a number of very concrete suggestions for possible projects at the end, realizable in Greece. So these 4 entities that create these crossroads are humans on the one hand, robots on the other, coming into interaction with humans, then vision and computer vision systems, but also human vision, which can be sold, if you want, as part of a service, as you shall see. And finally, social networks in their enlarged version, which includes both humans participating in social networks and social networking sites, as well as machines. And in the past, I have explored a lot of combinations of these 4 vertices. As you can see, for example, in the following video, which is from the Interactive Robots and Media Lab, the lab that I had founded originally in the United Arab Emirates.
His name is Ibn Sina, named after the ancient philosopher renowned for his early scientific discoveries. But unlike his older counterpart, this Ibn Sina is altogether more high-tech. As well as being fluent in English and Arabic, he can hold a conversation with humans. He looks for information about us on the internet and uses that to chat with us. He'll also remember it for the next time you meet. But this lab isn't in Japan, China, or the United States. It's in Al Ain, just an hour's drive from the UAE capital, Abu Dhabi.
So my talk will have 4 parts, roughly. First, I will talk about how we got here, and I will get a much more macroscopic approach, if you want. Then I will ask where do we go from here and give you a lot of examples from existing work in my lab and relevant work. Then humans entered the picture, and with humans we had the first man-made objects, such as tools, and very soon we also had machines in the last hundreds of years, which are quite different than tools because they have the ability to move on their own and autonomously. Intelligent machines are something that exists for roughly 50 years one way or another. The big question, though, is how much have these intelligent machines changed our lives? And just think of yourselves. In the last month, how much time have you spent interacting with other humans face-to-face? Versus how much time have you spent interacting with other humans through mediated means, be it a phone, be it a chat server, and so on. And finally, how much time have you spent interacting not with humans, but with a website, or with an electronic game, or with an ATM? And the average American is spending something like 2 hours online, and a very big part of this time has to do with direct human-machine interaction. So they are entering our lives, and we're starting, if you want, to relate with them in many respects. And then came robots, and robots are quite different than computers. So robots do not need a human to be sitting at their keyboard to be bringing the world to them, but they can directly sense the world as the first organisms could do. So they have computer vision systems, they have laser rangefinders, they have 100 other types of sensors. then again, they don't need a human to be controlling them as a tool, but through artificial intelligence, in the cases where they're autonomous, they're able to affect the physical world through motors and actuators. There are cases, though, where artificial intelligence nowadays can far surpass human intelligence. For example, Deep Blue won over Kasparov. But in many other respects, still humans have an advantage. If you have a look at the motor capabilities of the best biped robot that you have, they're much below what a 5-year-old girl has. And if you have a look at the learning capabilities of a small child when it comes to its ability to autonomously explore the world and hierarchically, if you want to learn, they're much higher than any autonomous learning system that we have. On the other hand, both for humans and for machines, having an isolated intelligence doesn't bring you very far. From the moment that you are able to take part in groups, and from the moment that by taking part in groups, in synergistic groups, you're able to achieve much, much more as compared to what one could do alone. But the intermediate stage, if you want, between the isolated intelligences and groups or teams of humans and robots, as we shall see, is the pair configuration, which is very, very important. So a single human and a single robot in interaction, which is the setting of most of the research that I have done so far. Let me give you 3 quick examples. This is the robot replay from MIT, and here my purpose was to turn it into a tabletop assistant that can converse with a human and can help him carry out tasks on the table, and at the same time to research language learning for robots. So this is replay following heads, and this is replay in verbal interaction.
At the top.
Look at the center.
Okay.
So the robot's camera sees a part of the world. This is on the upper right. And now the red object is not visible, but it can still talk about it. What color are the objects?
One is red and the other is green.
The robot can also take information about the world through language without having seen an object, and then creates a sensory expectation for the future. Where is the blue one?
Most probably at the left.
How big is the blue one?
I have no idea.
Look at the left. And now the expectation has to be compared with reality. It's either fulfilled or it's not fulfilled.
Okay.
In which case the human is a liar. How big is the blue one?
Small.
So it was fulfilled, and now the robot knows more about the blue object. How big was the blue one when your head started moving?
I have no idea.
Then we have a simple episodic memory, and you can query it and ask about past events.
Where was the red one when the green one appeared?
Most probably at the top, but maybe not.
Thank you.
You're welcome.
So there's much more to say about this project, and the robot can also manipulate objects and give them to you. It can, if you want, recognize human interactions with the object by tracking hands and so on. Let me give you another example from later from the Emirates. This was funded by Microsoft External Research. So here my purpose was to build a robot that can have multiple interactions with a human over a month and keep the interest. And the basic hypothesis was that if I create a robot that has shared memories and shared friends with a human, and for that respect I use both face recognition and an episodic memory in the robot, but also Facebook, then the conversations will make it more interesting for it to sustain the interest of the human and create a relation.
Are you able to tell me?
Yes.
Able to tell me? Are you doing well today?
Yes.
Well, let me tell you some updated news from the world of technology. The games industry has condemned. Have you heard about this?
No.
So you can have customized news,
And the latest steps on Facebook. It is working hard.
then information about the human or common friends through Facebook.
No.
I am sending you an inbox message about this. one of the common friends had
Then
a
you can
tooth
connect an
lost.
online human with a physically present human, and you can get people to meet that do not know one another.
I remember when we talked this morning, Don, I had asked you about, are you doing well today? And you were doing well, and I talked a little about chanting the tech. Anyway, it was nice speaking to you. Goodbye for now.
And then you can remember physical meetings, and you will see much more that we did, including a patent on social networks and robotics in the later parts of the talk. So third, museum robots or shopping mall robots or robots that can act as interactive theater actors. And let me give you an example of that. I cannot see the cursor. I can actually.
Okay. They are using it from remotely.
Okay, good. So this is the humanoid Ibn Sina,
مرحبا.
created in my lab. It has facial expressions, 30 degrees of freedom. It can converse with people in pretty noisy environments with, of course, a very simple chat bot, basically 10 categories of questions. And here you see emotions.
التصديق disbelief. متحمس excited.
Then we started also playing with teleoperation, and we had a number of things that culminated to full telepresence in the robot. I will show you one of the early projects. So here you see a human controlling a robot arm that could be far away by moving his hands. And there's much more in this direction that's useful actually for difficult environments and so on. But moving on from pairwise interaction, the next stage is groups. And the basic idea there is, N humans and N machines working under a common goal. Here you see a human-robot group from a NASA project. And the next stage is collective intelligence, where you could have, even hundreds of humans and machines collaborating. Let me give you a quick example of that. So this is from the DARPA Network Challenge in 2009. It's called the 10 red balloons problem. So here the task that DARPA gave, which is a defense advanced research projects agents in the States, was to put 10 red balloons in unknown locations in the States and get the teams that partake in the competition to try to find where they are. And the team that won from the MIT Media Lab was actually able to utilize social media in order to get thousands of people to give 10 seconds of their eyesight to the system and report whether they see the balloons or not. And keep this in your mind, the basic idea is crowd servicing. We're actually using human sensors, be it eyes or ears, and human mental facilities, recognition of balloons, that are given to us for a number of seconds. And that's all. So it's similar, if you want, to these hundreds of eyes in the peacock tail, but it's human eyes coming in and out of the system, and then through the network, we're getting the information that we need and completing our task. And this is not very different than collecting hundreds of thousands of photos or tweets in the Arab Spring and being able to get them concentrated in order to have a good situational awareness of what's happening. The overall idea is crowd servicing, people giving you short-term services, not necessarily specialized people, and these services are not just cognitive services, but they could be with their hands and with their eyes. And our proposal, again, from my lab regarding that, is called the Human-Robot Cloud Proposal. There's a number of papers, and the idea is that we use cloud technologies to include human services, but also to include sensing and actuation services by people giving reports with their eyes, cameras and other sensors, as well as human hands, humans moving things with cars, UAVs, and robots. And you bring all of this together to create the intelligent entity that you want on the fly by renting the components. It could be, for example, a huge system that's overlooking a city, the traffic control of a city, or moving things in a city at the same time. So it's not just the eyes on the peacock tail, but it's more like the 1,000 hands in the reincarnation of the Buddha, and each hand has an eye on it too. And again, the big question regarding the way ahead is what will we have in 50 years from now? And we're going to have a much more diverse ecology of intelligent entities, and we will be interacting with them every day. So, there's smart environments, smart buildings, there's going to be lots of different kinds of prosthetics together with robots and virtual characters. And the big question is, how do we bring all of this together in order for it to become not a utopia, but a nice place to be, and certainly not a dystopia. Now, third and fourth questions. What's happening in the world and in Greece? 2008, computer science publications, research output, complementary to the economic figures that Vangelis gave. The States is up on top, but then you have China. Now this has reversed. China is number 1. The H index, of course, of the States is much higher than China, so the equality, at least as measured by that, is still very big. Greece is in number 20. And if you divide with the population of these countries, another picture emerges. So who do you think per capita is the number 1 country in the world in ICT publications? Singapore, actually, and then Hong Kong. This is what it was in 2008. And in Europe, it's countries like the Netherlands and Switzerland. But these are very special cases. And Greece is pretty high up, too. Now, if you have a look at the trends, how things changed in the last 50 years as compared to now, so 2009 to 1995 versus 80 to 1994, another picture emerges. The States and Western Europe is stable. The Soviet Union has deteriorated. Eastern Europe and Southern Europe is coming up a little bit, and the huge change, again, is in China, Iran, Emirates, Turkey. But except for China, Iran, and Turkey, in the other places, the baseline is very low, so it doesn't really make any big change. Now, this is interesting, because when it comes to the academic part of things, robotics and AI in Greece are in a very good stage. And I've been with the World Robotics Olympiad teams. I was actually sent over to represent Abu Dhabi, and then I got to know them. I've talked with them. Also, when it comes to kids, I'm involved in the Hellenic Artificial Intelligence Association, and we have very nice young professors that have made their circle in the world, many of them, very good academic potential. And at the same time, we have the makers clubs and other grassroots movements, so nothing is missing regarding that. You have both the academia and the schools and the kids. But if you have a look at robotics companies, things are not so good. So these were 4 of the players that one could select from the last years. And 3 out of 4 of them are almost non-existent at the moment. And some of them had quite a size too, right? So Xenon Automation was outside Athens. Talos was a small company from Drama that exported sort of robots that are able to mix dyes for the textile industry in about 100 different locations in the world. This was again acquired by others and then pretty much died. 3 Sigma was down in Crete, and they were making UAV targets to be used in military exercises. EADS, the German aerospace industry, acquired them, and now they're almost non-existent too. So there's a big question, why is this happening? We have the academic potential, we have the young people, why? Well, I think the answer is the obvious. No real seed funding, only later stage and if. Unpredictable tax and legal framework. I was speaking at one point with Ilya from Skolkovo in Russia in a meeting that we had, and he told me, what, Nick, what we tried to do, of course, a different question whether it worked or not, is for Skolkovo, we have a different framework. So it doesn't go through the normal legal system, it doesn't go through the normal tax system, and in that respect, we can have something that operates irrespectively of what happens outside. And maybe it's time for us to start thinking in a similar way too. Of course, it's difficult politically in Greece. Then we have a lack of a grown-up local ecosystem. There is, but not really there yet. Of course, you have the European Union to help you with it and the other companies in the Union. You cannot, for a small company, how can you go out and find clients and export if you think how things are helping? So there's a big void there too. It's not only Organismos Proorthis Exagogón. There needs to be other supporting structures for getting you there. Then how do you get all of the different kinds of certifications that you need for a small company? And finally, when you market a product in the States, it's easy. You can almost at once market it in all of the States. In Europe, every country has different regulations. So it's a much more difficult situation. Okay, this was the negative side. Now let's see what is on our side to make it. Great human resources. And I don't know if I'm overemphasizing, but I think that there is pretty good quality available, and at this moment, actually at an extremely competitive price when it comes to Greece. And this is a unique opportunity. Then we have an innovative and creative mentality, I think, when we are put in the right context as Greeks. We do have a world network, which we're not utilizing the way that we could. And, you know, there's so many Hellenes and Philhellenes, or, you know, even people that are liking technology and robotics that could work and act as mentors. And there's so many ways to tap into, you know, foreign business networks to get the markets that you need. And finally, we have the ecosystem of the European and the Mediterranean, if you want, countries. So 4 different kinds of opportunities. I will be very brief. First, interactive robots for museums, theaters, receptionists, and so on. And you've seen a number of examples. And also, of course, for household helping. Here there's also Indigo from Demokritos, the museum robot that was used in the Hellenic world. Then, much simpler than robots, you don't have hardware. Just get 3 kids, you know, 3 kids that are university age. You know, they have their own laptops, you don't even need laptops, and get them to start doing machine vision code. And there's 100 applications for machine vision that are very easy to start playing with, and dedicated applications. You know, we've played with, you know, vision for transportation and car parking, vision for agriculture, a lot of applications in Greece, vision for retail, vision for object recognition, vision for UAVs, and so on. Very easy. You can even do it with, you know, good undergrads at the last year. Number 3, data mining. Again, MATLAB, R, data sets, you're done. You just need the brains and small teams. And even more so, data mining from social nets, which we have some extra experience, and biomedical data mining. And number 4, exporting human services, but higher level services, but again, for small time slots. See, we have all of these academics in Greece, which are, well, academics, PhD, if you want, holders in Greece, right? Which are not being utilized at the moment. Down in Africa, there's open universities starting up, and there's not enough personnel to do the training and the tuition. Can we find a way to channel, you know, some of our man-hours towards these countries? And this will also have a very big effect, not only in terms of the monetary return, also in terms of the fact that it works as cultural diplomacy. At the same time, we have, you know, medical experts and so on. Can we start selling telemedicine services and so on to the third world? Open opportunities. So let me just recap. I just talked about how we got where we are in the very big picture and where we go from here when it comes to robotics. I talked a little bit about research and entrepreneurship, the big picture, and then Greece. And I gave 4 examples of areas of direct opportunities for startups in Greece. Let me finish with a small fragment from a text that we actually wrote in one of the movements that I'm in, that has to do with a small part of a wider vision of Hellas. It's an interesting text. If you're interested, I can give you the references to read it. So we're willing to build a Hellas in which anyone will be able to transform his creative dreams into reality, beneficial for the common good, through his work, through friend groups and societies in which he's actively participating, and especially through a strong and well-supported culture of innovative, export-oriented entrepreneurship. And I think this might be a big part of the way out of what we are in, and a big part towards the realization of our dreams, and the MIT Enterprise Forum could well play a very important role in that. Thank you very much.